Now let's look at the domain and range of square root functions. So basically we're combining two things that we already know. First, in order to graph y is equal to a square root of x minus h plus k. And if you need to review that, then there's a video called Graphing Square Root Functions. And then the second one is domain and range. And there's a video for that called Domain and Range from Graphs. So all this video does is combine the two. So let's look at that. Let's look at an example. An example is to find the domain and range of, let's do y is equal to the square root of x plus 6 plus 5. So the first thing that we do is we want to sketch the graph, and then we read from the graph. So let's sketch the graph to start with. So if we want to graph y is equal to the square root of x plus 6 plus 5, well, the trick here is we don't actually need to graph everything. All we need to know is the starting point and then whether or not it flips or not. So first of all, let's find the starting point. The starting point in this case is going to be a negative 6 and a positive 5. The starting point is always hk, and the h changes signs and the k does not. So that's going to be 6 minus 6, 5. So if we look at that real quick, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Minus 6, 5 is going to be right there. So then what we need to know is we need to know whether this one flips or not. So what we do is we look at the A. The A here is 1 and it's positive, so if the A is positive it doesn't flip. So you know this graph is going to look something like that. If you wanted to, you could do a table of values to get a better sense. This is x and this is y. Starting point, put the starting point here, that's minus 6 and 5. Choose two other values for x. Doesn't matter which two. I'm going to choose, let's choose 3. Why did I choose 3? Because 6 plus 3 is 9, the square root of 9 is 3. That's going to be easy to figure out. And then choose another x value that makes this so it's a perfect square. So let's choose 16, let's choose 10. And then you can find the y's by plugging in the x and the y. So this is going to be y is equal to the square root of 3 plus 6 plus 5. 3 plus 6 is 9, square root of 9 is 3, so that's going to be 8. Then plug in 10, and I get y is equal to the square root of 10 plus 6 plus 5. 10 plus 6 is 16, that square root of 16 is 4, so that's 4 plus 5 is 9. So we could plug in actual numbers and we'd get 3. 1, 2, 3 is equal to 8. And 10 and 9, and we get the same basic graph. Now what we do is we want to read off the domain and range. Domain is we look at the x-axis and we say, what can x be here? Well, x can be anything from negative 6 to positive infinity. Does it include minus 6? It does. So that's a closed dot. So that's the domain right there. So the domain here is going to be x is greater than or equal to minus 6. Let's look at the range. Draw a dotted line over to the y-axis. That's 1, 2, 3, 4, 5. It's a closed dot, so y can be 5 and everything more positive. So the range here is going to be y greater than or equal to 5. If we want to do this in interval notation, the way we say domain is everything starts at negative 6. It goes to infinity, positive infinity. You always start with a more negative number. It includes 6, so that's going to be a closed parentheses. With infinity, we always use open parentheses. It's not necessarily important why. Let's look at the range. The range is everything from 5, and including 5, and more positive, right? We just read that by reading across. y is greater than or equal to 5, the most negative number is 5, and the most positive number is positive infinity again. We include 5, so it's a closed bracket. So you don't need to do both of these, it just depends on how you want the notation. That's written in terms of inequalities, and this is written in terms of intervals. Let's do another quick example. So find the domain and range and let's do something a little more complicated. Let's do y is equal to minus 1/2 square root x minus 4 minus 3. So the first thing I do is I find the starting point. The starting point here is going to be a positive 4 and a minus 3. 1, 2, 3, 4, minus 3. That's going to be the starting point. Now, does it flip? This one, the a is negative, so it flips. So rather than starting here and going up, this one's actually going to start here and go down. And that's actually all you need here. Draw a dotted line to the y-axis and to the x-axis. This is 4 and minus 3. The domain here is going to be everything from 4 more positive. So the domain here, x is greater than or equal to 4. Let's look at the range. The range is everything from -3 and then more negative. So it includes minus 3 and everything more negative than that. So it's y is less than or equal to minus 3. You could plug in numbers if you want. You could do a table of values if you wanted to, and that would check your answer instance to make sure it goes down. The key is, though, that this flips, x and y both move in the same direction forever. So x continues to get larger and y continues to get more negative. If you want to do this in interval notation, the domain would be more negative number is 4, and it goes to positive infinity, so it's 4 comma positive infinity. It includes the 4, so that's a closed bracket. With infinity, we always use an open bracket. Y is the range. We use everything. Now here we go. What's the most negative? The most negative is actually minus infinity. So we go from minus infinity to minus 3. So whenever you do interval notation, the more negative number always comes first. So that's negative infinity to minus 3. With the infinity, we always use an open parentheses. Here, we do include minus 3, so it's a closed bracket. And that's how you do domain and range of square root functions.